Today we're going to start by first looking at these equations. We're going to start by first looking at these equations. So we solved those equations first, which had no compound angle expressions in them, no double angle expressions in them. But what you should know is that it's not always that you're going to be given a straightforward question. Sometimes they'll try to complicate it by putting a double angle formula or a half angle formula within that same equation. So let's see how you go about with such equation. So first of all, like this question here, A, is a cos theta. And according to what we learned last week, we know to say this sine 2 theta is also just the same as 2 sine theta. Two sine theta and then cos theta. So after these equations, we are moving to sketching the graphs. Then after sketching the graphs, then we call it a day, and then we are done with trig. So that next time we're going to meet, we'll quickly go into complex numbers, and then by next week, maybe we should be done with complex numbers and start matrices. So this is equal to 0. This is the first question there. So we know to say this sine 2 theta can also be written as this. Then after that, we can factor out the cos theta. You can factor out cos theta here, and then you have something like this. Cos theta, then open brackets, you have 1 minus, this is 2 sine theta. This is what you're going to have. Then this being equal to 0. So here, cos theta is either cos theta is equal to 0 or say that cos theta is equal to 0 or 1 minus 2 sine theta is equal to 0. Now, so from there you can now find theta. You can take this part first and then come and take the other part at some point. So you can now find theta to be equal to just the cos inverse of 0. Then we know to say the cos inverse of 0 is nothing but 90 degrees. Then cut like that. So this 90 degrees lies in the first and in the fourth quadrant. Since cos is positive in the first and fourth quadrant, this 0 is considered to be positive when you're dealing with angles. So in the first quadrant, theta is just the same, this 90. You take the same 90. But in the fourth quadrant, you have your theta. Being equal to 360 minus 90 minus 90. Okay. Then this theta, when you subtract that, you find your theta to be 270. But the question is, are the angles or is the domain given in radians or in degrees? If the domain has been given in degrees, you can leave them like this. But since it's in radians, you are not permitted to leave it in that way. So meaning you can simplify it further by converting it. And the simplest way you can convert a degree measure to a radian measure is just by dividing by 180 and then multiply by pi. So theta in radian measure, you divide this by 180 and then multiply it by pi, you get something like 3/2 3 over 2 pi. So this is in radians. This 90 in radians, you get it to be, it's nothing but pi over 2. 90 divided by 180, you get 1 over 2 multiplied by pi, you get pi over 2. So we found two angles. We move on to this one. So this one, you make sine theta the subject. I'm trying to be fast so that we can finish trig today. I don't want us to remain with something to do. So sine theta is equal to, you move this one to the other side of the equal sign to be a -1, and then divide by -2, you have 1 over 2, that, like that. So now your theta will be nothing but equal to the sine inverse of half, the sine inverse of half, and then the sine inverse of half is nothing but 30 degrees. So the sine inverse of half is 30 degrees. This 30 degrees, since half is positive this side, so meaning sine is only positive in the second quadrant and in the first quadrant. So in the first quadrant, sine will be gotten as it is, which is 30 degrees. And this is going to be, in radians, it's 30 divided by 180. So 30 divided by 180 is 1 over 6. And then multiply it by pi, you have your answer to be pi over 6. Then this is in the first quadrant. And then in the second quadrant, you have your theta to be, your theta is going to be 108 minus 30 degrees. So 180 degrees minus 30, you get your answer to be 150 degrees. And then 150 divided by 180 times pi, you get your answer to be 5 over 6 pi. So your answer is going to be 5 over 6 pi. So this is your solution of sine in the second quadrant. And hence now, after doing all this, you just now put your answers together. So you say my value of theta is equal to, you write all the answers that you found which are within the given domain here. So the first one, the smallest one that we have there is pi over 6. Then after pi over 6, you have pi over 2. And then after pi over 2, you're going to have something like, oh, this is 5 over 6 pi. 5 over 6 pi. And then lastly, you write your 3 over 2 pi there. So you put them in the order starting with the smallest angle. So these are your answers for the first question there. I guess having known how to solve the first question, I think we can solve the second equation. Straightforward. We know what cos 2 theta is. We know cos 2 theta is just nothing but sine squared theta. Sorry, cos 2 theta. Let me just do this. Cos 2 theta, we know that cos 2 theta is nothing but equal to cos squared theta, then minus sine squared theta. which can also be written as 1 minus 2 sine squared theta. 1 minus 2 sine squared theta. Like that. So meaning where there is cos 2 theta there, you can replace with 1 minus 2 sine squared theta. And then you find you find it to be something like this. So where there is cos 2 theta, we put 1 minus 2 sine squared theta. And then you have your minus 3 sine theta, then minus 2 being equal to 0. Then from there you can say 1 minus 2 there, you get your answer to be negative 1. So when you simplify this expression, you're going to have something like this: 2 sine squared theta. When you simplify it and then divide everything by negative 1, you are going to have this 2 sine squared theta minus, plus 3 sine theta, and then this plus again 1, which is equal to 0. So here you just say let, for simplicity's sake, let x be equal to sine theta, so that while there is sine theta, you replace with x. So meaning you're going to have something like 2x squared plus 3x and then plus 1 is equal to 0. So this is what you solve. You solve this quadratic equation, then find your solutions. After finding your solutions, you recall that x is equal to sine theta. Then you find your values of theta. Anyway, let's proceed. Let's now move on to today's work. So this is just the same solutions that I was solving. Okay. So we move on to trigonometric, or sketching the trigonometric functions. So what you should understand on these graphs is that they just come out the same way. What normally differentiates them is the phase shift, and sometimes you may even be given the domain where the graph is supposed to start from and where it's supposed to end. And then I think that's the only difference. And then even the angles. But otherwise, the graphs only, the graphs, if it's sine theta always comes out the same. Cos theta always comes out the same. Tan theta always comes out the same. But for you guys, I think looking at your tutorial sheets, I didn't see any graph for tan theta there. So meaning we're going to restrict ourselves on sine and cos. So the sine graph always comes out like this. This is how a sine graph comes out. It's always like this. Whether we change numbers, we do what, the only difference that is going to be between this and the one that we're going to have is that this same graph here will just shift. It's either to be like compressed or to be shifted up or downwards or to the left or to the right when we change, when we play around with numbers here. But otherwise, the graph always comes out the same. So for sine, it always comes out like this. If it's a negative sign, it will come out like this. This is negative sign. Yeah. So if it's positive sign, it will come out like that. If it's negative, it will go down like that. So cos, this is how cos comes out. If it's negative cos, it comes out like that. So negative cos comes out like this. Then to pass there, then go like that. But otherwise, they all come out the same. They are not different. Let me also show you a tan graph. This is how a tan graph comes out. So in your tutorial sheet, I didn't see these graphs, so I've not prepared any questions about this. All right, so let's proceed. Yeah, by the way, there are some terms that you need to understand on these graphs. The words like amplitude, phase shift, you need to understand what the, okay, let's look at them. So the amplitude there is nothing but the height from the center line to the peak or to the trough. So when you have your graph like this, and then this is your sine graph, the amplitude is just the distance from the peak there up to the center line. So this is going to be your amplitude. So the number here, the number that is going to be here is the one that is going to be your amplitude. So your amplitude, you can be given a positive amplitude, it doesn't matter, but just know that that same positive number is positive and it's negative at the same time. So it can be like that. So the distance from the center line to the peak is the amplitude. Yeah, so that's what I was talking about. That's the amplitude there. And then when you have been given an equation like this, if you've been given an equation like this, the amplitude is simply the number that is just outside here. That is just outside the trig ratio. That is the amplitude. So this is the amplitude here. So in this equation, our amplitude is A, given this equation. And then I'll explain what this B means, what that C means, and then what that D means as well. So when you see, like for instance, here we have a negative sign. The graph that is here is for positive sign there. But if there's a negative like that, the graph is supposed to go down first like that, then come back like that. That is the graph for this. I just hope that you are following. We move on to the next word, which is the period. So the period is just so the period of a sine curve or of a cosine curve or of a tangent curve is just the length of one cycle of that same curve. So the period in physics is sometimes defined as the time taken for one complete oscillation on pendulums. The time taken for one complete oscillation. So one complete oscillation is just the same as one cycle. So the period for this, for example, the period for this is just from this point up to that point. Because from this point up to that point, from this point up to that point, you know, you can attest with me that this curve has moved one cycle. From that point up to that point, this curve has moved one cycle. And then the period, when calculating, it's found by, so the period is calculated by, you say 360 degrees, meaning one complete cycle, and then divide by B. What is this B I'm talking about? This is the B I'm talking about, this one here. So you divide 360 by B, or if it's in radians, it means that you're going to divide 2 pi by B. That is in radians. Okay. So we proceed. So that is the period. It's just the time taken, or it's just the length of one cycle from this point up to that point. That is the period of a sine curve or a cosine curve, or or a tan. So we proceed. So that is what I was talking about. The period is calculated using that formula. And then B, this is the B that I'm talking about here. And then we have the vertical shift. The vertical shift is just D. D. In this equation, this is the vertical shift. So it can either go up or down, depending with the sign that has been given, that is with this D. So if D is positive, it will go up. If D is negative, it will shift down. What do I mean by vertical shift, or what do I mean that it will shift down? What will shift is the center line. So this center line will shift. Quite right, we're going to have our 0 there, but we're going to shift our center line. If this D is 2, it means that we're going to shift it down there. It means that we're going to shift it to down there. So we're going to have it there. If our vertical shift is 2, it's going to shift to there. So that is how. All right, sorry for that. Let's continue. So I hope you can all get me. Okay. So I was talking about the vertical shift. The vertical shift is just this D. So it's either positive or negative. If it's negative, it means that the center line will shift to the negative going downwards. If it's positive, it will shift up there, meaning this graph, if it shifts up, meaning instead of starting from here, from this 0, it's going to start from somewhere there and then go up, go down like that. That is how it's going to be. This is the work of the vertical shift. So we can also look at the phase shift. So the phase shift is just like, I would say, the opposite of the vertical shift, because for it, instead of moving the graph either up or down, it moves the graphs. It moves the graph along the x-axis. So for this one, the phase shift, it determines the point where you're going to start drawing your graph. So from this equation, you just get this part here in the equation, and then you equate it to 0. You equate that part to 0. That is what I just did there. You equate it to 0, and then find the value of x. So once you find the value of x, that is the point. That value of x, that is the point where your graph is going to start from. So if your x is 0, meaning your graph will definitely start at the 0,0 point there. And then if your x is, maybe you find your x to be 2, it means that your graph is going to, instead of starting at 0, it's going to start at 2. So the phase shift moves the graph, or moves the sketching, moves the curve along the x-axis. So it starts like that. That is how it's going to be. So we proceed. Let us first try to look at one example. We'll see what we're talking about. So when you look at A here, when you look at A, since we've not been given the domain, the question is saying find the period, the amplitude, the phase shift of the given function and draw its graph. So A is simply f of x is equal to, so we are going to have 2 sine. When you multiply 2 times x there, you have your 2x there, and then 2 times negative pi, you have your negative 2 pi, like that. So what you do here, you first identify which one is your amplitude, which one is your phase shift, your vertical shift. Yeah. So your amplitude in this case, we said, according to what we said here, the amplitude is just this number here, which is just outside the sine or the trig ratio. So the amplitude will be nothing but equal to, okay. So the amplitude will be nothing but equal to 2. It's just this number here. This number here is the one that we're calling the amplitude. And then from finding the amplitude, you quickly find the period. So the period, we said, it's just nothing but, since we're in radians, we're using pi, it's just nothing but 2 pi divided by this b here. So our b in this case is 2. So 2 pi divided by 2, which will give you 2 pi divided by 2, you get your answer to be pi. So this is your period. So it's going to take pi radians, it is going to take pi units to complete one cycle. So after finding the period, they are also asking us to find the phase shift. So the phase shift, like I earlier on said, I said you just equate what is in the brackets here to 0. So the phase shift is going to be, 2x minus 2 pi. You equate that to 0. Then you get your answer. So if you equate this to 0, you find your answer x to be, you find your x, just remaining 8 minutes. Let me finish this one, then I'll generate another link. So you find your x to be pi. This is your phase shift. So after finding the phase shift, I said the phase shift is sometimes called the starting point. That is where the curve starts from. And then we also need to find the ending point. Where is this curve going to end at? So the ending point, I always call it the end point. The end point is nothing but just adding the period to the starting point. So the period plus the starting point, you get, let me just use x on starting point because that's the one that we're using there. So x, so period plus x gives you the point where you're going to end with your graph. So our graph is going to start from pi, and then it's going to end at pi plus pi, like that. And then when you add the 2, you're going to have 2 pi. So if we're to draw our graph here, I don't know if I've left anything, period, amplitude, phase shift, or found everything. So in this case, we don't have any constant this side, d. So meaning our vertical shift is equal to 0. We don't have d this side. So meaning our vertical shift is 0. So from there, we move on now to sketching the graph. So the graph is going to be like this. So you have your 0 there, starting point. Let me just draw it properly. Okay. I'll draw it like this. Okay. So you have your 0 there. And then after that, you can put your starting point, which is your pi. I'll put it there. Then from pi, I'm going to have my 2 pi there. I'm going to have my 2 pi there. So from here, you can now, if you want to know now the divisions here, this is why a lot of people get confused. How am I going to know what I'm going to put in between here? You just divide your period by 4. So when you divide your period by 4, you are going to have, when you divide your period by 4, you are going to have your answer to be, so period by 4, we're going to have pi over 4. So pi over 4 is going to be equivalent to 1 division from pi. So I'm going to add pi over 4 plus pi. I'll get something like, is it 5 pi over 4? And then 5 pi over 4 plus pi over 4. Also, yeah, 5 pi over 4 plus pi over 4. I'm going to get 6 over 4, which is just the same as 3 over 2 pi, which is going to be there. 3 over 2 pi. And then lastly, I'll have 1 division there, the last point, which is going to be 3 over 4, I mean 6 over 4. We found 6 over 4, and then I just reduced it. 6 over 4 pi. And then I'm adding it with the division that I found, which is pi over 4. Pi over 4. So when you add the 2, you find your answer to be, is this 7 pi over 4? Yeah, I think 7 pi over 4. So having found this, it's now easier for us to draw the curve. So we know that this is a sine curve and it always comes out like this. So that is a sine curve.
Mr. Teddy.
Yeah.
Why are you adding pi over 4 to everything?
Okay, I'll explain in the next question that we are going to have. Since it's almost time up, let me just finish up this one.
Oh, okay.
Yeah, I'll explain it clearly. Okay, so the sine curve always comes out like this when it's positive, and then when it's negative, it comes out like that. So now, since in our case here, it's positive, it means that it's going to come out like this. So we're going to start from there, and then we look at now the amplitude. The amplitude is 2. So I'll put my 2 there. I'll put also negative 2 there. So my curve is going to move like that. My turning point will be there, and then it's going to cut this line of axis there. Then it goes down up to the negative period, and then comes back there. So this is how my curve is going to be. This is how my curve is going to come out. All right. I think in this remaining 2 minutes, I can explain I can explain why I was adding this pi over 4. So what you should understand is that if you've just been given direct this question to start solving, I mean to start sketching, you do everything. You know the starting point, which is x, and then you also know the ending point, like we did there. We reached some point which was like this. We had the pi there, then we had 2 pi there. But how are you going to divide this? If you don't want to be adding that pi over 4 I was talking about, you can just find the midpoint of that. You find the midpoint of pi and 2 pi, but that one is dangerous. A lot of people get it wrong. You find the midpoint of pi and 2 pi. The midpoint of pi and 2 pi, you find it to be 3 pi over 2. And then you also find the midpoint of pi and 3 pi over 2, you write it there. You also find the midpoint of 3 pi over 2 and 2 pi, you write it there. If it's easier for you that way, you can go with it like using that way. So that pi over 4, what I was saying is this. The pi over 4, if you have something like this, okay, if you have something like this, so instead of you finding the midpoints and everything, you just divide your period by 4. So my period in that case was pi. My period was pi, and then I divided it by 4, which gave me pi over 4. And then this pi over 4 is the one that you now add to pi. When you add it to pi, you find the division there. When you add it to this answer that you're going to find there, you find your answer there. When you add it to this answer there, you find your answer there, and then you are done. So just divide your period by 4. That's so, and then you start adding to the units that you have in your x-axis. All right, so we move on to the next question. So here, I don't know which one we can do, but I think this one is just the same as this one. The difference is not that. Okay, Christine. Christine, you can speak.
Hello?
Okay, I'm getting you.
I can't get you properly.
Could it be? Is it everyone who is unable to get me clear? Or maybe try to see if your network is just okay where you are.
Okay.
All right. So we can proceed. Okay. So let's begin. So I was saying this one and this one, they are not very much different. They're almost the same. So let me do this one, and then lastly, I'll do that one. We move on to those that have domains. So for a cosine graph, we know to say it always comes out like this, or like this. So this one is positive cosine, this one is negative cosine. So B is saying the f of x, or maybe instead of me writing this, let me just write B, because time is not with us. So we know that from here we can tell to say our amplitude is equal to 1 over 2. It's just this part here. This is your amplitude. And then this side, when you open the brackets, you are going to have something like, let me just write it here quick. You're going to have something like, you're going to have this, and then this is cos, open brackets, 3 times x, you get your 3x, then plus 3 pi. Okay. So from there, we can now find the period and the phase shift. So the period, we said, is nothing but Since our angles have been given in radians there, so we'll say 2 pi instead of 360. Say 2 pi over b there is 3. So this is our period. B, you just get this, the coefficient of x. And then we also find the phase shift. The phase shift, you equate 3x plus 3 pi. 3x plus 3 pi, you equate it to 0. And then you discover that your value of x, when you simplify there, you get your negative pi. And then when you look at this, excuse, when you look at this, this is also referred as your starting point of your curve. So let us now find the point where it's going to end. The point where it's going to end, we said it's given by the period and plus the value of x. So in this case, we're going to have 2 over 3 pi, and then the value of x is negative pi. So when you subtract that, you find to say your endpoint is going to be negative pi over 3. So from here, we can now even go straight into sketching. So this is going to be something like this. So you write your 0 there. Oh, sorry, let me just write it properly. So we found our amplitude to be, made a mistake to erase everything at once. So to be half, and then our period was 2 over 3 pi. Then our starting point and end point was, our starting point was negative pi. Then our end point was, so our end point was negative pi over 3. So I erased everything by mistake. So let me now go straight into sketching the graph. So the graph will be like this. Let me write it here. So I know to say my amplitude is half, meaning even this side I'll put negative half, like that. And then from there, my 0 is here. And then just by inspection, you can know that pi should be somewhere there, negative pi should be somewhere there. And then pi over 3, I'll put my negative pi over 3 there. So here, it's a little bit tricky, as I said. So to find the divisions between, I said you divide your period by, 4. So when you divide that period by 4, you get something like pi over 6. When you divide this by 4, you get something like pi over 6 as your answer. So we're going to be adding pi over 6 to the divisions of this. Now, since I know that I'm going to the negatives, I'm going to subtracting them instead of adding them. So I'll say 1 over 3 minus or plus, depending with where you're going, which direction. And since I know that I'm going back, I will say negative 1 over 3 minus 1 over 6. So it's giving me negative half. So I'll put negative half there. So it is negative pi over 2. and then I'll put my other one there. So I'm going to add the same number again. So that is going to be negative half minus 1 over 6. Negative half minus 1 over 6 gives 2 over 3 pi. So this would be negative 2 over 3 pi. And then lastly there, I'll add again negative 2 over 3 pi minus pi over 6. It will give you something like, that is, should be 5 over 6 pi. Yeah, something like this. Then after finding the divisions in between there, now you can easily sketch the graph. So remember, for sine or for cos, it's something like this, or like that. That is for cos. So what you do here is, the network here is not very much stable. Okay. All right. So what you do here again is you look at your amplitude there, which is half. So I'm going to start sketching this graph from my amplitude level there. Then I'll go down like that. I'll cross the axis. I'll cross the axis at the first point, and then my lowest point will be on another amplitude half, and then I'll cross the axis there, the fourth point, and then that is it. So this is the graph. So if there was a negative this side, the opposite would have been the case. It would have been come out like this. It would have looked like this. Now, since it's positive, it's going to face up like that. So this is how you sketch the cos graph. So I've looked at sine and cos. Of course, the last two that we've looked at do not have the vertical shift. Now let us take one which has the vertical shift. Let us look at the last one here. The last one here is f of x. Okay, this is f. Yeah, this is f. So from f we can tell that our amplitude, start with the amplitude, we can tell that our amplitude from f is equal to this number here, which is 2. So our amplitude is 2. We look for the period. The period is nothing but 2 pi over this b here. My b there is 2. So 2 pi over 2 gives me pi. So pi is my period. And then from there, I'll also find the phase shift. The phase shift here, I'll just equate what's in the brackets there to 0 and solve the equation. So this is what is in the brackets. Pi over 2 is equal to 0. And then I'll solve the equation. So when you solve the equation, you find out to say your starting point is, I think, should be pi over 4. Like that. When you solve this, you make x the subject. Of course, you take this pi over 2 to the other side of the equation, and then divide by 2. You get pi over 4, and then here now we can find the ending point. Let me find the end point. So the end point here now is just given by the period, we add the period to x. So the period is pi. So I'm going to add pi plus my value of x is pi over 4. So this will give me 5 pi over 4. You close like that. So from there, we know to say our vertical shift, I will denote it as V or D. Let me just put it using the letter that somebody used. So our vertical shift is equal to -2. So meaning our graph is going to shift downwards by -2 units. So I'll draw this. Of course, I'm going to draw smaller ones like that. So this is my 0 axis. Then from here, what I'm going to do is I'll put the period. Okay, let me draw the shift first, which is the line of axis, meaning to shift to -2. So I'm going to draw my -2 there. Then it will be something like that. Okay, so after drawing my shift there, it means that if I'm to put now the amplitude is 2. So I'll add 2 to -2. When I add 2 to -2, I'm going to get 0. So meaning my highest point is going to be in this axis here, the 0 axis. And then if I subtract -2 from -2, I'm going to get -4 somewhere there. So this is the axis where my lowest point is going to be. And then from there, I can now start sketching my graph. I'll put my first point. My graph is going to start from pi over 4. So I can do this if I want. And then it's going to end at 5 pi over 4. 5 pi over 4. So now let us find the divisions. Let's find the divisions now. So the divisions that are going to be between here, so it's going to end there. Now the divisions that are going to be between, just the period divided by 4. So when you divide the period by 4, you're going to have pi over 4 as you're going to have pi over 4 as your answer. So I'm going to be adding pi over 4 to everything. So pi over 4 plus pi over 4, you find your answer to be, is it 1 over 2? Pi over 4 plus pi over 4, yes, you get your answer to be pi over 2. And then pi over 2 plus pi over 4 again, you find your answer to be 3 pi over 4. 3 pi over 4. Then you add another pi over 4. You add another pi over 4, you get your answer to be a 1. And then 1 plus another pi over 4, you get your answer to be 5 over 4. So when it gives you 5 over 4 as the last point here, in the process of adding, just know that you are correct. You are going to easily draw the graph without making mistakes. So I'm just sketching these points so that it's not difficult for me to come and sketch my graph. So I know this is a sine graph. This is a sine graph, and then this sine is positive, so meaning it's going to come out like this. So my starting point is pi over 4, meaning I'm going to start from there. And then my amplitude is 2. So meaning I say, if you remember, I said that my highest point is going to be and in the 0 axis, and then my lowest point is going to be in the negative 4 axis there. So I'll start like that. I'll go up, come down. Then my lowest point is there. And then that is it. So that is how my graph is going to look like. That is what my graph is going to look like. So this is how you sketch graphs. It's as simple as this. So we've done a sine, a cos. We've also done one which has the vertical shift. So now let us now move on to graphs with a given domain. Here we are not given the domains. We are just making our own domains here. In short, we are making our own domains in the sense that we were finding the first point where we should start from, and then the last point where we should start from. So if this domain was to be given, if the graph for this domain was to be given, it would have been like this, pi over 4, then maybe they say less theta less pi over 5. This is what would have been, or 4 pi over 5. This is what would have been given as the domain. Meaning they are telling you that the graph is starting from pi over 4 up to 4 pi over 5. But sometimes they can give you a domain which exceeds which exceeds the period, because this one is just one period. So sometimes it can be maybe 2 periods, 3 periods, or 4 periods, depending with what they want. So let's move on and see when you've been given the period. Let's move on. Let's check. So okay. So this is what I was just doing. This is question A. Let's move on. Okay. So this graph, this is question 15 from your tutorial sheet. Sorry. This is question 15 from your tutorial sheet. Let us just see how you sketch this given a domain. So I'm going to do, maybe I'll do the first one here. If time is going to be enough for us, I'll even do another one. So let me do the first one here. Since we know how to draw these graphs, so it will be easier for us. So this is, let me do this. Okay. I made a mistake without removing this. Anyway, let me just, I'll do it quickly down here. So this is A. So A is f of x is equal to 1. Let me just copy it here. So f of x is equal to, this is 1 minus cos x. And then the domain that has been given is from 0 to 2 pi. So we need to restrict ourselves during this same domain. So let us just draw this. So our value, so this is going to be the 0 axis. This is the x-axis, and then this is the starting point. Since we know that we're going to start from 0 to 2 pi. Since we're going to start from 0 to 2 pi. And then I'll write 0 there. Okay. So This is it. So now we can start first by finding the period. The period there, or maybe we start with the amplitude. So our amplitude from question A, our amplitude is, you just get the coefficient of this trig ratio here. So my amplitude there is 1. And then my period there it would be nothing but 360, or since my given what domain is in radians, I'm going to say 2 pi divide by, so I'm going to say 2 pi divide by, the coefficient of x there is 1. So I'm going to say 2 pi divided by 1, 2 pi divided by 1, which will still give me 2 pi. So according to this question, I think we're just going to move one cycle because the domain is saying that we start from 0 up to 2 pi. And then we've discovered that our period is 2 pi. And then let's find the starting point, rather the phase shift. So the phase shift is, we said you equate what's in the brackets. In this case, what's in the bracket is just x. So this question is straightforward, simple and interesting. What's in the brackets is just x. So my x, I'll equate it to 0. So meaning my phase shift is just 0. So I'm going to start from 0. I said x is also the starting point. So I'm going to start from 0. And then where am I going to end? So the ending point, remember what we said? The ending point is just nothing but period plus, so it's just nothing but period plus the value of x. So what is the period? The period is 2 pi. This one, we found period to be 2 pi. And then that is our period, and then you add it to x. What is the x value there? Is 0. So we're going to end at 2 pi. So for this given domain there, it's just showing us to say we just have to move one oscillation, one cycle. So we can start sketching the graph. So we're starting from 0 and then ending up to 2 pi. So if you want here, you can say the half of 2 pi is pi. Or maybe let me show you the one I've just been using from the beginning. So I'm going to divide my period by 4. So when I divide my period by 4, it will give me 2 pi. This will be 2 pi over 4. And then 2 pi over 4 will be nothing but 1 over 2 pi. So 1 over 2 pi, I'm going to be adding 1 over 2 to everything here. So when I add 1 over 2 to 0, 0 plus 1 over 2, I'll still get 1 over 2. So 1 over 2 pi, I'll still get 1 over 2 pi. And then 1 over 2 pi plus 1 over 2 pi, half plus half, we all know that it's pi. This is the pi that I wrote here. The time I was saying the half of 0 and the number between 0 and 2 pi is pi. And then from there, pi plus 1 over 2, we're going to get something like 3 over 2 pi. So this is what we're going to have. But remember, this cos is negative. So if it was positive, the graph would have come out. So first, before I even start talking about that, let me put my amplitude. My amplitude is 1 and negative 1. So remember what I said, if this graph was positive, it would have come out like this. Now instead, now since this cos is negative, so it's going to be something like this. So we're going to have something like this. That is the graph that we're going to expect. So, oh no, just remaining with 10 minutes. Anyway, let's see what we can do in this same 10 minutes. So it's going to come out like this. So instead of starting there from positive 1, it's going to start from negative 1 and then go up. It's going to start from -1, then go up to 1, come down. Uh-oh. Okay. So it's going to be like this. Come down. Yeah. And then up to that point again. So now imagine, since the time is almost is actually even up. So now imagine that this domain that was given maybe up to somewhere 4 pi. Like how you can see how C is ranging from -pi up to 5 pi. These are ranging from pi up to 5/2 pi. These are very big ranges. So now imagine instead of them maybe giving us 2 pi, imagine that they gave us something like 4 pi there. If they gave us 4 pi, let me do this. If they gave us 4 pi, it simply means that this would have kept on going. So 2 pi plus pi, 2 pi plus 1/2 pi, you keep on adding like that. So you get something like 5/2 pi. Then you add another 1/2 pi. You get 3. Yeah, you get 3 somewhere there, 3 pi. Now they want us to end at 4 pi. And then you move on again. You add 1/2 pi. You add 1/2 pi, you get something like 7/2 pi. 7/2 pi. And then you add 7/2 pi plus 1/2, you get your 4 there. So the domain, if the domain was ranging from 0 to somewhere maybe 4 pi, this is how it's going to be. It's going to keep on going up to somewhere 4 pi like that. It's going to go like that. So after that now, you don't have to end at your end point. Our end point was ending at 2 pi. So this was just showing us where our first cycle is going to end. So now let us keep on moving now. So we are going to move like that up to 4 pi. We're going to move like that up to 4 pi. So this is how the sketch would have come out if we were given 4 pi here instead of 2 pi. So this is how it would have come out. And then after that, I'm going to yeah, actually, since time is already up, as you can see, it's counting down. So I think for the sake of revision and practice, I want you guys to do the questions that we have not done. And then you send the solution. You can do from the previous slide here. From the previous slide. So yeah, from the previous slide, you can do at least maybe 1 or 2 that we have not done. Sketch it, and then take a pic, take a photo, then forward it to my WhatsApp line. I guess you all have my WhatsApp line. So forward it to my WhatsApp line, and then I want you to, I want to see whether you're understanding or not. Then again, what you should do is same applies to question 15 here, the last question that we have done. I think you guys can do the same. You try to solve. Yeah, I was talking about question 14 here. So try to solve maybe E and D, or even C if you want, just to check whether you've understood or not. And then on the next slide here, you can solve one of the remaining questions, either B, C, or D, just for the sake of understanding. And then once you finish solving them, you can forward them to my WhatsApp line, and then I'll check through where you are missing it. Then I'll explain to you just there on WhatsApp what you're supposed to do. So you can do that. So thank you for your attendance. I just hope that you've understood trigonometry from where we started. This is our last lecture that we had on trig. So the next lecture that we're going to have, the next lesson that we're going to have, the next lesson that we're going to have is going to be complex numbers. We're going to start complex numbers, and then I'm sure it should not take us maybe more than 3 lessons to finish complex numbers. We need to move at a very fast rate. And then at the same time, you also guys have to be understanding, because the exam is around the corner. It's just maybe 3 weeks from now, 2 to 3 weeks from now, or less than 3 weeks. So I want us to do as much as we can. Before the exam, at least maybe we should go up to, if he's going to release a module for calculus, if your lecturer is going to release a module for calculus, it would have been better by the time he's going to be releasing, we are done maybe with these topics that he has already released, so that when the moment he just releases, we even start calculus as early as possible. All right. So see you in the next meeting. Shalom. Or if you have any questions, by the way, you can ask before we end in this same last 2 minutes we have. If you have any questions, you can ask. Any questions? Any questions? Any questions? Okay. I know some of you feel shy to ask questions from this platform. You can inbox me your questions. I'll still answer. I'll still respond to you. But I believe when you ask it here on public, you would also help others with the same question. Anyway, let's meet on Friday to start complex numbers. Yeah. So I'm ending the meeting.